Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. So good day everyone. Okay. So everything in this slide is prepared in Malay. So I'm sorry for that. But I try my best to deliver as well in English. So okay, again I would like to thank the former research group leader, okay, Dr. Muhammad Adham. So here I am. Inshallah, I try my best to lead this RG. Okay, for another 3 years, inshallah. So my experience during my what we call as kind of a practical training, or in Malay latihan iktisas, is part of the sabbatical leave that can be taken by the UTM staff, academic staff, okay, which is happened from 1st February 2021 until 31st January 2022. So I did this practical training in Global Sdn Bhd, which is located in Shah Alam. Okay, so a bit of overview or the content of the agenda of my presentation. So the motivation, why I want to go for practical training, and what are the scope and commitment during the practical training, and what lesson learned. Okay, I have gained from this sabbatical. Then the motivation. Yeah, the idea is just came when MZR Global approached me for some project collaboration. So when I think about it, why not? Okay, I take this opportunity, and at the same time, I can complete them as a practical training. Okay, sabbatical leave during my sabbatical, and also again, yeah, this I have to complete this practical training for the purpose to get promoted. And also it is a way to breaking the norm. Okay, the last I returned from PhD is somewhere 2011, so now 2021, about 10 years hustling the teaching and learning, research and everything. So why not take a leave, breaking the norm? So yeah, preparation to go for practical training. Okay, everything can be referred to this website, UTM CDEX. Here, the checklist. You must get the supporting letter. Should be your director aware of this, your administration aware of this. Okay, from their approval. Okay, the details checklist can be referred from the UTMC deck. Then, okay, here, this is the MZR Global Sdn Bhd. This is the place where I undergo my practical training. So it is a software house that provide computing solution, software solution, I guess, and the creative services. And this is the CEO of MZR Global Sdn Bhd. Of course, he is 1 year younger than me. So for the scope, project scope and commitment, okay, basically, okay, I already break them into 4 category. I mean, based on the submission, on the progress submission that I have submit to UTM. Okay, the first project that I involved is known as a Jendela DBP project. Okay, actually, when you can Google this Jendela DBP, already uploaded. Okay, already live to be used by the whole user. Okay, then I also responsible to help MZR in preparing the proposal. Okay, the proposal of technical proposal for any system that they want to apply. Okay, to bid. Okay, then I also again preparing the technical system for the maintenance phase, and the last ones that I commit is prepare the initial proposal for DBP translation. Okay, so basically job spec is involved in requirement engineering and testing phase, and also project management. So the lesson learned, okay, that I gained from the first project, Jendela DBP. Okay, Jendela DBP. Okay, so the main challenge is the development, the whole system, the development only took 4 months. Then since it happened during COVID time, okay, with the restriction movement order, then everything need to be settled remotely online. Then we have to dealing with the migration and integration exercise that really challenging. So those are the very challenging part, okay, in developing this Jendela DBP. Okay, of course, okay, to develop the software, we should have this kind of process model, okay, to be implemented, to be applied, right? So do you think, based on these challenges, okay, I want to throw a question. I want to get opinion from you all. Okay, based on these challenges of this project, okay, do you think what is the best or the ideal software process model to be used? Okay, please try to scan this QR code and try to answer what is your option, what is your best software process model. Please, everyone, help me. Okay, so agile, so 100% agile. Yes. Why agile? Because it was developed in a very short period. So agile is the ideal solution for this project. So yeah, when the developer decide to implement okay, to use agile methodology, another challenge have to let the but to train, okay, to teach our user, our customer about this methodology, agile methodology, because they only familiar with waterfall methodology. Okay, this some part of the sharing that I share with them, which methodology, agile methodology basically support the deliverable, and okay, we have this kind of versioning, okay, compared to the waterfall methodology, which is every phases need to be is constrained, okay, cannot move on until you complete phase by phase, right? Then yeah, again, how we relate the reality of the theory of the agile, okay, then relate with the list of submission here. Then every deliverables or artifacts will have several versions, okay, that should be tallied in every sprint of meeting, and so on. So here are the deliverable. Yet even though the MZR have these tools, ClickUp, but we cannot utilize the tools because of apa ni, time constraint. Tak sempat nak belajar pun, tak sempat nak explore habis. So I just straightly suggest them to use Google document, yeah, shared only. Then the challenge, one of the board director mentioned about CRISA guideline, okay, documentation guideline that which has been proposed by Mampu, okay, which has been proposed Mampu. Okay, actually Mampu just proposed this guideline, so it is not really yet popular among the government agency, but soon, okay, sooner or later it will be fully apa, government agency has to adopt this kind of guideline. Okay, so masa tu BOD asked me how this guideline can be mapped with all those documentation that we propose within Agile, and all the things should be tally also with the quotation at the first place. Oh, kan? Macam-macam mapping lah kena buat apa semua. So this kind of presentation I made, okay, to convince them. So I can say that the critical success factor of this project is okay, the challenge is the project has to develop remotely, online, among of the team, okay, developer kat rumah masing-masing, requirement engineer dekat rumah masing-masing, kan, end user pun, kan, unit-unit dekat rumah masing-masing, kan, masa tu mereka pun boleh datang office pun bergilir, dan saya pun jumpa end user ni memang via online saja. So, but still, Alhamdulillah, this project managed to be delivered in on time, and one of the critical success factor is cloud application, okay, penggunaan aplikasi dan teknologi secara awan ni lah, okay, dan dedikasi dan komitmen yang tinggi oleh ahli pasukan projek, the team, very committed and dedicated. Waktu tu dah termasuk waktu apa ni, puasa dan sebagainya, okay, dan kami sangat beruntung dapat user yang sangat dedicated. Dan kita nak buat meeting dah petang sangat ni pun dia orang sanggup lagi committed. Okay, then the challenge sebab pembangunan projek ni sangat singkat, then that's why we propose agile methodology. Okay, then we propose submission artifact yang secara bertahap dan berkala, incremental and versioning, usage of temporary UAT and user story. Okay, so ini adalah template UAT yang saya gunakan lah. At the same time, kita attach sekali business process S2 untuk dia get supaya dia clear. Kita capture sikit dia punya screen supaya dia clear lah functional yang dia kena test dan sebagainya. So next project, saya pun terlibat dalam penyediaan proposal cadangan teknikal ni. So ini antaranya lah sebahagian yang lain. So satu adalah quotation tentang projek CIDB. Okay, kalau ini nampaknya dia bukan macam minta software development, not really focus on the software development. Dia macam minta initial study. Okay, initial study, okay, melaksanakan kajian terhadap keperluan data analytics CIDB. But within the initial study, they need us to come up with the mock-up. What is the best process model, okay, to propose for this solution, kan? So of course bukan agile lah untuk yang ini masa tu. So next kita tengok yang ni, contoh lagi satu, Majlis Bandaraya Iskandar Puteri minta upgrade dia punya web portal. So yang ini saya nampak lain ialah the features, one of the features, one of the exercise yang being requested is integration to the perkhidmatan SPLUX di Mampu. Okey, apa itu SPLUX? Oh, kena study lagi. Satu Mampu sediakan satu servis di mana dia boleh track you punya web portal kerajaan ni, dia tracking lah. Sama ada banyak hit ke, popular ke, banyak penggunaan ke, dan macam-macam lagi lah. Dari segi security-nya elok ke apa ke, those kind of macam-macam lagi. Yang dia track, yang dia tracking lah, tracking system untuk portal-portal government agency. Rupanya, kan. So kita kena mereka Mampu ni ada service, API service yang dalam coding setup government agency ni kena embed. Okay. So yang satu lagi saya rasa mencabar ini adalah satu tender berkaitan dengan maintenance, maintenance sistem pengurusan material tentera darat. Maintenance. So bila maintenance, oh okay, apa proses model yang terbaik untuk kita guna pakai? So itu of course again kat sini pun bukan agile. So terpaksa study lah. So the last penghujung praktikal saya again with DBP request for initial proposal for their translation system, English to Malay. English, Malay, English translation system. So this is what I propose for the initial framework architecture. Okay, so insyaAllah tomorrow we are going to have follow-up meeting. Okay, so tomorrow evening I will be in KL to discuss with them. Okay, so Okay, from my story. Okay, what do you think was the real challenge I faced? Again, please, everyone, try to answer this in the Mentimeter. COVID. Yeah, sure. COVID, yeah, the main constraint, limit everything, cannot face to face. Yeah, dealing with the client request, yes. True, because I have one guy in this one of the client that really that always not agree with us. Understand the existing process, yes. Yeah, too many process. Okay, too many business process. It's hard to understand them, but alhamdulillah we managed to short period of time to do that. Yes, yeah, it is very challenging, and it's good to experience them. So we really apply the theory of agile, and we managed to. Mm-mm, betul, sangat pantas. Kena belajar things or everything, tapi tak sempat pun nak explore lebih. ClickUp tu jadi tak boleh utilize langsung ClickUp tu, tak sempat. Okay, I think yeah, true. But for me, the real challenge that I face is actually preparing the closing report that requested by UTM. This is the by the time I want to submit the final report, UTM just produce this kind of very new template with this kind of content. So yeah, but I believe that not all the content that we can easily write, okay, reflect, okay. So yeah, for me this is the most challenging part lah. So anyway, I hope my story uh benefit to some of you. Okay, I guess that's all from me, Lukman. So maybe you also ada soalan ke nak tanya?
I'm Johanna, Dr. Roha.
Yeah.
Maybe you can share with us the sweet memories that you have during your training.
Okay. Among the sweet memory, yelah sebab kita tak dapat sangat nak face to face, so kita tak boleh ada very close relationship with the end user kan. Tapi pengalaman yang antara pengalaman paling manis adalah bila saya berjaya untuk present pada end user tentang agile methodology, the solution dan implikasinya kepada DBP itu sendiri, ketua pengarah mereka sendiri sangat-sangat teruja. Oh, rupanya memang ada solution ini yang lebih in trend dan oh selama ni dia pun tak tahu. Dia sangat-sangat teruja dan berterima kasih sebab ada knowledge baru yang dia dapat. Okay, at that time I feel I am nobody. Saya rasa macam tu lah. I am nobody. Then okay, people yang yalah ada kedudukannya say thanks to you because of the ilmu tu. So it is among the sweetest time lah. So jadi what I learn is jangan takut lah, kan? You sendiri ada capability, you sendiri ada wisdom, so go for it. Buatlah, do your best. InsyaAllah akan memudahkan orang lain. Itu sajalah.
Thank you.
Okay, welcome.
I have a question. So you mentioned just now you use the agile method, right? Development. So how do you handle the documentation like SRS, SDS? So usually we learn complete documentation then done the development. So how in agile the documentation?
Okay, documentation agile. Kita rasa kalau dalam teori tu some of the statement tu kata kalau agile dokumen sikit, betul? Dokumen taklah sebanyak yang macam waterfall ke whatever. Pada saya tak semestinya. Dia agile ini adalah saya boleh kata dia incremental. Dia support incremental and iterative delivery. Okay. Macam projek ni kita ada beberapa sprint sampai sprint 8. Maksudnya satu sprint tu dalam tempoh 2 minggu tu akan ada milestone lah. Ada milestone. So kalau ini list of document that we have to deliver to them. Right? So kita tak boleh nak kata dokumen tu sikit. Tapi because at the first place, the quotation said that you must deliver this kind of document and documents. Kan? So macam mana sikit? Sebab because when you fail to deliver, so you cannot claim the money kan. So somehow, but it is the way. You tak adalah kata pada sprint 1 everything need to be submitted at sprint 1. Because of the agile, dia support incremental development. At sprint 1, you just deliver version 1 which is consists of a certain module or certain functions kan. Then in the next sprint, you upgrade lagi the solution. There will be you complete another module, so you upgrade accordingly lah. Mana related document. So this is what we apply lah, what we have done lah for this project. Okay. So am I answering you, Luqman?
Yes, thank you, Dr.
Assalamualaikum, Dr. Roha. I'm Aziza here.
Yeah.
What do you think from the implementation of the development? We can proceed with the research for our group research. Is there any
Okay. Sure. Because inshallah I have a good rapport with DBP. So actually, yeah, tomorrow I'm going to have a follow-up discussion also with them. So of course, all those discussion is everything is for our group as well. So of course, once we can sign up any collaboration, okay, any any collaboration. So of course, I will introduce this group to them, one of you, every semua orang lah. Okay.
Okay, thank you.
Welcome. So I guess that's all from me. Okay. Thank you so much. Okay, for spending your time to listen to me to my story.
Okay, next, so I would like to invite Mr. Abubakr to start his research progress presentation.
Assalamualaikum everyone. Okay, I'm doing PhD on new IoT service selection model based on automatic user preference with Prof. Dr. Dayangs. So what we are doing, we are trying to propose a new service selection model for IoT services based on automatic user preferences. User selection, since nowadays we have a lot of provided services on the internet for cloud services, IoT services, traditional web services. So we need to have as automatic service selection to find a proper services for a user, or for the computer, for actuator, for a sensor, for anything. We need to have service selections model to select a proper services. Since now we have a massive number of the services available on the internet, definitely that will be a very difficult task to select a proper services among all of these services. So especially with the emergence of IoT services, this number have been tremendously increased because of the available devices and available actuator on the world. And then with increasing of these things, the number of services also increased. So we need to have a service selection model, especially for IoT. So the current, why we need a new service selection model, because with availability of different providers of services and different available services, with the high number of the services, we need to have a good model to select a services, to select a proper service for a user. And if you want to select a service based on the functionality, you may get a lot of services that provide the same functionality. In that case, you have to distinguish between different services, like having a service with a good quality of services. Then you can find the proper services. So different provider may have a different quality of services. Different service may have a different quality of services. Also, selecting service, deciding which quality of service is matter for a user is based on the user. So with a high number of the services, also with many differences in the quality of services, also with the many differences with the number of the quality of services. So we have a number of quality of services differences also, which are available on the internet. So in that case, we need to have very good model to select a service based on the quality of services, based on the user preference, based on user context. So the current works on the service selections either works on the quality of service based only quality of service, or quality of service with user context. Also, some of them try to use the user intention for service discovery, not select. So since we have a high number of services, also we have a different number of quality of service for each services. Also, we may have a different taste of the users to select a service and different preference of users. So this is why the various approach, the previous approach, try to use the weighting approach, try to provide the weighting approach for quality of service. They try to have to give a weight for each quality of service to find out which quality of service is more important to the user and which is less important. And the current approach, as I use the direct weight for each quality of service, when we are talking about quality of service, to select a proper service, they try to use the previous one, direct preference of the user for each quality of service. Like a user will add its preference, how they want to have their quality of services to select a service. Some other works try to provide to propose. They propose objective weighting for quality of service, like entropy weight. Some other researchers they propose objective weight for quality of service, like TOPS's hierarchical analytical approach. So some other studies, they focus on finding, instead of weighting the quality of service, they focus on finding unknown quality of service. This is why they propose the recommendation approaches for finding quality of service values. But none of these works, or the previous works, try to use the user intention, the previous or the history of user intention with user context to find user preference. The current approaches either is based on the objective weighting approach or based on the subjective weighting approach, like MCDM approaches, like TOPS's. Also, some of them try to find the weight for each quality of service based on the frequency of using a services, but none of them try to use the user intentions and the user context together to find the user preference. That's why we try to use user intentions and user context together to find user preference without any user interaction to put its preference to find the proper services based on the user preference. So the problem statement of this research is the current weighting mechanism of user perspective are based on predefined user preference or is based on subjective weight, which will be based on the expertise opinion, or based on the objective weight, which is not applicable for IoT services, since we have a highly dynamic context in the IoT. Also, we have a lot of available services, so user cannot add its preference for each kind of services. So also the user taste or the user preference may change based on the domains. Like the user may have a different preference for the healthcare services, may have a different preference for travel services, may have a different preference for temperatures services, or may have a different preference for any other kind of services for a different domain. This is why the current weighting mechanism is not prepared for this kind of selections. The objective weight does not reflect the user preference or the user desire. The subjective weight are based on the expertise opinion, which also does not reflect the real intention or the real desire of the users. Also, the predefines user preference for each quality of service based the user itself. It will be a difficult task, and it will be impossible for IoT services actually, because when we are talking about IoT service, we are talking about the high dynamic context, a high number of the services, like having a person or a user in a smart city. They can interact with the services, the hundred of services at the day. So the neglecting domain and user intention of the quality of service weighting lead to retrieve undesired service and decrease service selection accuracy. This is why the research question will come up based on the problems that we discussed. It's how to select IoT service based on automatic user preference and intention. And we have some sub questions from the main questions, which is how to detect user intentions based on user context and request, how to predict user preference weight to increase automation accuracy. Also, we have to answer why cannot a specific set of weights answer service selection for a different domain, how to utilize user preference and intention to find a proper weight for quality of services. So the objective of this study is to propose new service selection model, IoT service selection model, based on user context and intention, and evaluate the proposed model based on the performance and accuracy. To propose predict the user preference based on the user context and intention, to propose new selection algorithm to reduce search space and increase selection accuracy. So for that purpose, we analyze the current or the previous works in our literature. Basically, we discuss about IoT services, what's Internet of Things, web services, and also we discuss the context, the user context, service context, and also we discuss a user intention in the literature. Also, we are trying to use a clustering to find the user preference. So we discuss the clustering approaches in service selections. Also, we discuss service selection approach, the current service selection approach, and the current service selection approach in IoT as well. Then we have a comparison of the existing approach and a summary at the end of literature review. I'm not going to discuss all of this. I just put the chart of the literature review just to show you how we make a study. So from the through what we discussed, we found the problems in the current approach for service selection and IoT, which are heavy description of IoT services, lack of dynamic context support, lack of automatic weighting and intention consideration, lack of considering user weights, then return desired services, considering user preference. You can have we found a problem in all of these sectors, but what we are focusing on, this part, lack of automatic weight and intention consideration, then considering user preference as well. So the proposed model for IoT service selection, we propose that model. We try to use in our model, we try to use the user intention and user context to find out the user desire or the user preference. Then based on the found user preference, we select the services, return the desired service for the user. For that purpose, the first thing that we have to do is to get user invocation history, the history of user intentions, the previous invocation of the services. Then we find intention based on the period of time. So we calculate, you will get the intention of each user based on the period of times, like the previous, the service that's selected in half hours, the service that have been invoked in an hour, in half hour, based on predefined thresholds for a times. So we will get all the invocation of the services in a period of time. Then we say that this invocation on that time is one intention of the user. We say that the selected services in the period of time can reflect one intention of the user. Like user within a half hour try to book a flight, then a book hotel. Then we say that the book flight and the book hotel together is one intention for the user. So let's say the user try to book an operating room for operations in the hospitals. Also, it's called for it asks for emergency services. So we say these two services together are one intention of the user. Also we can have a mixed domain, like a user book flight, then ask for booking a doctor. Then we say the user travel, but the intention of the travel is to visit a doctor. So the services that have been invoked in a period of times based on the predefined threshold, we say that those services are one intention of the user. Then, since we are going to have a lot of previous intentions, a lot of histories, we need to minimize the domain, minimize the previous intentions. So for a search, so we need to have a clustering algorithm. So we propose a clustering algorithms. Before that, we have to make a similarity between each intentions, different intention and different user context, based on the semantic similarity, also a Jaafar similarity. So we have combined the Jaafar similarity and semantic similarity together to find a similarity between two set of service invocations, like two intentions. Then we cluster the user intentions and user context based on enhanced hierarchical clustering algorithms. Then we find a similar intention of the user from the similar user intentions. For example, we say the users try to book a hotel. Okay, for the book hotel, we say the intention is the traveling. But when the user try to book a hotel and book a doctor, then we say the travel intention is for visiting a doctor. A booking hotel is for visiting a doctor. So we find that intention based on the user selection, based on the user invocations. Then you will get the previous quality of service of the previous invocations, of the history of intention for that similar intention, for that intention. Then we use enhanced entropy method to calculate the weight for each quality of service. Then we filter the quality of service, which quality of service is important and which is not important based on the value of entropy method. Then we use a dynamic p-dominant skyline algorithm to select a service. You may have a 10 quality of service, but based on the algorithm that we run here, we find out the most of the weight is for only 4 quality of service. So from that case, we will find out only those 4 quality of service are important to make a selection based on. So we filter the quality of services and the value of quality of service, the weight of the quality of service. Then we use those weights in a service selection based on dynamic predominance scaling. How we can find the similarity for intention? Each intention is for each user is based on the verb and the target of the user, like book hotel. That's one invocation, what the user wants. What the user want, for example, book hotel. Book is a verb and the hotel is a target of the intentions. This is based on the predefined data sets for Niger 2015. So for making a similarity, we have 2 things. We have intentions and the context. So we make a similarity between 2 sets of the intentions and the context of the user to find a similar user and similar intention of the user. This is an example of intention. For example, we have a book hotel. That's only one service invocation. The second invocation of the user is get map. Then the third one is reserve Safari. If you just try to call one service, you may have a different preference. But the book hotel with get map, then we will find out that the book hotel and get map is for traveling purposes. Then when we reserve a Safari, then we know that this intention is only for traveling purposes. But let's say have a different if you have a different intentions, different invocation sequence like find hospital, get map, and reserve operating system. In that case, you say get map here is not for the traveling purposes, not for the tourism purposes. It's for finding hospital, not for finding hotel or finding reserve Safari places. So you may get a different quality of service preference for these services. This is how we make a similarity between 2. This is an intention example, by the way, and that's a user context. For the user context, we have the context model. Sorry, for the context model, we have entities, we have representation and the scopes. For example, maybe the service requester is not a person all the times. You may find a device that call for a service or any other objects that call for a service. So we find out which entity are calling for a services. Then we find out the representation of the entity and the resource. Then the scope, the entity may have they may invoke a service in a different time from different devices, from different locations, or with a different profile, or with the different resources. For example, you may have a device that has got a service with different resources or in a different location. This may result in a different intention and different preference for quality of service weight. So for weighting prediction approach, we are going to use intention and the user context. So first we prepare data, then we find the similarity. The data is based on the user intention datasets from the Niger Works 2015 and OWL's TC4 datasets, and we pick only 3 because we have several, I think, different kind of domains that are available for OWL's TC4 datasets. We just pick healthcare and education travel domain. So our evaluation is based on those 3 domains. Then we find semantic similarity plus you use semantic similarity and Jacker similarity to find a similarity between user intentions and user context. Then we apply clustering algorithm. Then we apply enhanced entropy weight to find the weight for each quality of services. How we calculate the similarity between 2 intentions and 2 user contexts. Then we calculate semantic similarity for intention based on the verb target, like book hotel. So we will find a similarity for between each of these invocations, single invocations, like book hotel with get map, book hotel with find hospital, book hotel with get map, and book hotel with reserve Safari. Then we calculate the semantic for user based on the user context. You may have a different user context based on the context model that we have here. Okay, so we will find a similarity between two users. Then we partition the collection of the user intentions. We picked the collection of invocation, and we call those as a single as an intention of the users. In our example, we use 30 minutes, and the previous work also, some of the previous works use 30 minutes for service intention and service history. So we partition all the user invocations within 30 minutes. Then we calculate the similarity. The second similarity is the calculate similarity between this intention as whole with the other intention as whole. Also, for calculating this intention with the other one, we also consider the sequence of the intentions, like the book hotel comes at the first invocation and the get map the second, and so on. So we weight each of these service invocation in the intention based on its sequence with other set of the invocation. Then we calculate the similarity of these two intentions based on modified Jaccard similarity. After getting the similarity between two set of invocation or two set of intention and context, user context similarity, you will get the similarity matrix. And then based on the similarity matrix, you will find the clustering. You will apply the clustering approach to find the clusters. For that purpose, we propose enhanced hierarchical clustering algorithms. And the steps of that algorithm is to find, the first step is to find a neighbor, then merge the nearest neighbor, then merge members together. Then define this is what we do. Our enhancement, our modification is happen here, is to find the cluster center based on the density. The merge of the two cluster in the HCA, in the traditional HCA, either based on the average or based on the mean of the cluster, or based on the single linkage or complete linkage. What we do here, we find another way to find a cluster center for HCA based on the density. The intention with the highest density in the cluster will be a center of this cluster. Then, as a result, we will get the clustered intention and user context. In that case, when a user wants to select a user, so the first thing that the user do is to enter its intention, like book hotel. So based on the book hotel, we will find the proper cluster of that intention. Then we calculate the weight of quality of service based on that intention. As a result of our clustering algorithms, I'm just showing some of the results just to show the process how it's going. We evaluate our clustering based on silhouette evaluation and then index evaluation with accuracy. For silhouette evaluation, our proposed approach is higher than the minimum entropy clustering, also is higher than the traditional hierarchical clustering algorithm. In the index also have a higher than index than the HCA and minimum entropy clustering. Then we evaluate the clustering based on the accuracy, and the proposed accuracy, the proposed HCA accuracy is 0.86, which is higher than the other. You may ask why these are very low, because the data that we propose, that we get from similarity is quite noisy. There are a lot of similarity between each intentions. So it's very difficult to find the clusters, to get the clusters. That's why the previous ones have a low accuracy on that datasets in our dataset. After getting the clustering algorithms and the clustering data, we will calculate, for example, the user will find the intentions based on the cluster data. Based on the cluster data, we'll find the weight for each quality of services. For that purpose, we propose entropy weight, enhanced entropy weight or modified entropy weight. The traditional entropy weight will measure the value dispersion in decision making. So the greater the degree of dispersion, the greater the degree of differentiation. So if you have a more differentiation in the entropy weight, you will get a greater degree of dispersion. With the lower differentiation, we will get the lower degree of dispersion. This is the traditional entropy weight, which is calculate the weight objectively without considering the user intention. So we have for when you are selecting a service, the selecting services, or let's say the weight of quality of services, the weight of a service will be affected by the frequent invocation of the service. When we get a cluster, when we get our cluster for our intention, then we calculate the weight of the quality of service based on entropy. But in the entropy, we will focus on the frequency of the service invocation. Then we will focus on the user satisfaction of the user. For example, if you get a service with a response time 0.1 and throughput 0.1, as we see, the response time is very good, is very low, but the throughput also is very low. In that case, the throughput is not good, but we have a good response time. If a user try to re-invoke this service, it means the user importance is on the response time. The user will consider response time, is not consider the throughput. That's the first important things in this part. Since we say the user satisfaction will affect after user intention to reconsume the service. If the users try to reconsume the service, it means the user have interest to use that service again. But as you see here, this example, if we have a response time, very good response time and very bad throughput, in that case, when the users try to reconsume the service, it means the user is considering response time only, does not consider the throughput. The response time is more important to the user. That's the first thing that we have to calculate, we have to consider. The second thing, if the invocation, after bunch of the invocation of this service based on the similar user, based on the similar intentions, if you find out that the response time, for example, here we have a response time of 0.1, then it becomes 0.2, 0.3. If you find out the quality of service of response time, for example, is getting higher, it means it's getting worse, from the good to the worse. In that case, you have to give the weight, the lower weight for that quality of service. When we see if the response time is 0.1 here, then the second invocation became 0.2. The third one became 0.3. But still user try to reconsume the service. In that case, you say that user does not consider the response time. Why? Because the response time is getting worse, but still user try to reconsume. This is why we enhance entropy. But if you calculate the entropy weight for this data, okay, it will give, for example, you say the throughput is getting better, response time is getting worse, but as a result, you will get 0.5 weight for each. If you use the traditional entropy weight, you will get the same weight for each of these quality of service. But actually, this one is getting worse, but this one is getting better. In that case, we should consider this change in the quality of service. From this change, after consuming the service by the user or a similar user, we will find out that this service is important to the user, but as you see here, the throughput is getting better. It means the user try to have the same service because the throughput is getting better. It will not consider the response time. So as long as the response time is getting higher, the weight of the response time is getting lower, and the vice versa for throughput. How we can do that? By modifying the entropy weight, by modifying for this equation of Shannon entropy weight. Then we calculate a different m for the entropy weight. We calculate this frequency of the service invocation with the flow of the quality of service. So from here we can find out the desired weight for a quality of services. As a conclusion, we have used semantic similarity and Jaeger similarity to find the similarity for intentions. Also, we use the enhanced RCA clustering to find to cluster the previous intentions of the users. Then we use the modified entropy method to predict weight and to get the user preference for each quality of service. Then the result shows the higher accuracy in terms of the clusterings, but still I have one final result for evaluating the whole model, which is not here. Inshallah, as soon as possible, we complete this part as well. Thank you very much. If you have any question, that's all from me.
So I have a question.
Yes, doctor.
So, can you explain the accuracy value that you showed just now? What does a higher value means?
The accuracy is between 0 and the 1. The total, the corrected cluster data divided by the total data that we have, then we'll get the accuracy.
So what does it mean? Does it mean that higher value means better prediction?
The better accuracy, yes.
Okay, thank you.
Okay. Same for that index and silhouette. The silhouette value is between the 0 and 1. The higher silhouette, it means the higher the better clustering. Same for that index. The higher the index, it means the better separation between two different clusters.
Okay.
Okay, Assalamualaikum. I have a question.
Yes, Dr. Aziza.
Your domain is IoT, right? The domain?
Yes.
So from the data that you provide here, you will use OWLS, right? For the
OWLS. Yes, OWLS.
Okay. So is the OWL is appropriate for the IoT domain? I mean, because for the IoT, normally it's have a limited constraint of the description. So for what I understand, OWLS, the description is heavy. So is it possible for the IoT domain?
Actually, not. The lightweight description is much better for IoT, for mobile services, as you proposed in your work. But in my case, I am not, like say, my contribution is not on that part. I'm just using that to approve my hypothesis.
So later on, the evaluation will be used IoT or not?
For the evaluation?
Yes.
No, we are using same OWLS TC4.
Okay, so it means you. So this part is only for the clustering part, right?
This, yes, for the clustering, for the intentions.
Okay, it's okay, but you have to consider that later on. Okay.
Yeah, actually, let's say I didn't have resources like the available datasets for that. This is why I'm using the OWLS TC4. And most of the previous works also for IoT, same for IoT, they are using the same datasets, OWLS TC4.
So if there is justification, it's okay. If
the
other works for the IoT domain use the OWLS S, is okay.
Yeah, same. There are some other description. They use a different description for IoT devices, not IoT services.
Because the concern is the lightweight and heavyweight, right?
Yeah. This was available for me, the OWLS TC4, but I know that it's better to have lightweight descriptions.
Thank you everyone for the questions and comments, and also thank you again Dr. Rohayanti for the sharing and Mr. Abubakr for the progress presentation. So if there's nothing else, I think we can end our colloquium for today. Thank you everyone for joining today's colloquium. Have a great day, stay safe, and see you again in the next colloquiums.